So in this video, we're going to have a look at graphing this pair of lines on the same set of axes. So firstly, what we're going to do here is we're going to use this formula or this rule to fill out the tables that we have here. And then we're going to plot the dot points and connect the lines. So firstly, we'll start with the -3 here, and we're going to work our way across. So what we do here, substitute -3 in as x. So I'm going to write that down here. So we have y is equal to 3 multiplied by -3. So 3, and just put the brackets here so we establish that's a multiplied by negative. It's not 3 minus 3. And then we add 4. So let's move across here and solve this equation. So we need to multiply 3 by -3. So y is equal to 3 multiplied by 3 is 9, but because we've got a negative in there, a negative multiplied by positive is a negative. That's -9 plus 4. -9 plus 4, -5. So we've got y is equal to -5. So now let's substitute that into that table. So I've got here -5. So now let's do the same thing with -2. Let's go here, y equals 3 multiplied by -2 plus 4. Now we simplify this. 3 times 2, 6, but it's a -2, so that's going to be -6. So y is equal to -6 plus 4, which means our y value is equal to -6 plus 4 is -2. -2 in here. And I'm going to do it for one more value, and then we're going to walk through an easy way to move through the rest of it. So we'll do our -1 as well. Move that across. So y is equal to 3 multiplied by -1. So what I'm going to do, I'm just going to change the color here. This, and let's do a little box around those so we can see what their different solutions here, or different working out. Let's go back here. Y equals 3 multiplied by -1 plus 4. So then we simplify again. So y is equal to -3 plus 4. That means our y value is just equal to 1. So y is equal to 1 when x is equal to -1. So y is equal to 1. Oh, let's change that to our black. Y is equal to 1 here. So you'll see that for both of these steps, our y value has increased by 3 for every one x value across. And that directly links with this 3 here. So once we have our starting point, we can see that our y value is just going to go up by 3 every time we move across. So for every one x value across. So -3 to -2, that's one x value. So that's going to go from -5 to -2, which is go up by 3, which is this 3 here. That's our gradient or rate of change. So if we add 3 to 1, that'll give us 4. Then we add 3 to 4, that'll give us 7. Then we've got 10, and we have 13. So that's how we solve that. So let's do the same thing for the second one, but we'll just find the first point, and then from there we'll use that gradient or rate of change to find the rest of the table. So I'm going to remove all this stuff here. And we'll work through on this side. So I've got y equals, I'm going to get rid of that so we can see that graph, that table. Y equals 4x. So 4, our x value, we'll use a -3 again. So 4 multiplied by -3 plus 3. So we simplify 4 by 3 is 12. So 4 by -3 will give us -12. Y equals -12 plus 3, which gives -9, because we're adding a positive number to a negative value. So here we've got -9, and from there we can use the same process that we did for the second half of this first table, just for the rest of this one here. So we know we can have a look at our rule here. We can see that our gradient or rate of change is 4. So if it's going up by 4, so -9 plus 4 gives us -5. -5 plus 4 gives us -1. Then we have -1 plus 4 gives us not negative, gives us just 3. Then 3 plus 4 is 7. Then we have 2 plus 4, not 2 plus 4. We have 7 plus 4 gives us 11. And then we have 11 plus 4 gives us 15. Now, what we can do here, or what we have to do here, because the second half of this was to graph them both on the same set of axes. So if we look down here, I've marked out an axis here. Our y-axis is going up in 5 increments of 5, and our x-axis is going through in increments of 1. So we'll start with our red graph. We'll dot those, so plot those coordinates. So start with our first one. Here we've got x is -3 and y is equal to -5. Let's have a look here. So x value first, 1, 2, 3, -3 here, and y was -5. So let's plot that point here. Now let's have another look. -2 and -2. -2 here. -2 I think will be around there, just above that middle mark. Got -1 and 1, so -1's here, and then 1 will be around there somewhere. Got 0 and 4. 1 and 7. 2 and 10. So we know that'll be right on the corner there. Then we have 3 and 13. So that's our first line here. And then what we can do is we can just draw a straight line and connect the dots there. And that's relatively close. So these dots should all be around that straight line. So now what we need to do is we need to graph this second table of values. So we have a look, -3 and -9. Actually, I'm going to change my color to blue. Might use the bigger dot here, and we'll match that to the color we've got for the rule. So -3 and -9. So -3 is this one here. -9 will be around about here. So then we have -2 and -5. -2 here, -5 around here. Should be in line with this line there. -1 and -1. 0 and 3. 1 and 7. So if we have a look here, 1 and 7 is in both. So that is going to be our point of intersection. So that should actually lie on the other graph here. Then we've got 2 and 11. And 3 and 15. So, and then again, let's just connect those dots. And that line there is much better, it's much straighter, much more accurate. Finally, you need to make sure that we write out our rule for each one. So for this top one, let's have y equals 4x plus 3. And then the bottom one, y is equal to 3x. Let's try that x again. 3x plus 4.